This is the answer to Chapter 10, problem number 53 from the Smith Organic Chemistry textbook. And this problem gives us these 5 alcohols and says which alcohols can be prepared as a single product by hydroboration-oxidation of an alkene, which alcohols can be prepared as a single product by the acid-catalyzed addition of H2O to an alkene. So basically, we need to remember that hydroboration-oxidation is going to add the OH to the less substituted carbon, and the acid-catalyzed addition is going to add the OH to the more substituted carbon. So looking at number 1 here, let's go with green. Okay, so looking at number 1 here, this could be prepared from either of them. So this is going to come from this right here, and we could use either method, right? Because all the other carbons in this molecule are exactly the same, and this is a ring, and so we're not going to have any control at all, but all of the products are going to be the right product. So this could be either one. Okay, so then for B, we are thinking about how we can make this. So we can redraw the skeletal structure here. Okay, and so we need to put a double bond somewhere in this that we can add the alcohol selectively. And so we want to put the double bond here because if we put it there, it's between a secondary carbon and a tertiary carbon, and that gives us the opportunity for some control. And so we want to add it at the tertiary carbon, which is we want to add it at the secondary carbon, which is another way of saying the less hindered carbon, the less substituted carbon. And so hydroboration oxidation is how we're going to do that. So hydroboration oxidation. Okay, so that's the answer there. So then looking at C, C is going to come from here, or C could come from here. But in either case, if no matter where we put the double bond there, in both cases, it's between a tertiary carbon and a secondary carbon. And this time, we want to add the alcohol to the tertiary carbon. And so the acid-catalyzed reaction will accomplish that for us. So we'll call this acid-catalyzed. Okay, so then looking at D, D is going to come from here. And in D, like in B, we want to add the alcohol to the less substituted carbon, and so we're going to need hydroboration oxidation. Okay, so then looking at E, E is sort of going to be a problem, right? So for E is going to come from here, and we can put the double bond here, or we can put the double bond here. But in either case, the double bond is between 2 secondary carbons. And so both hydroboration and the acid-catalyzed hydration will give us a mixture of products. So there is no good answer here. And that's because, remember, selecting between hydroboration oxidation and between acid-catalyzed hydration really allows us to select between secondary and tertiary carbons as to where we want to add our alcohol. And in this case, all of our carbons are secondary, and so neither tactic is going to give us solely the product we want. We'll get some of the product we want, but we'll also get a mixture with the alcohol at the other carbon. And so there's no good answer there for E. Okay, and so that's the way to approach this problem. Just draw, the backbone that you're starting from. Think about where your double bond has to be, and then think about which reaction you want to use in order to put the alcohol where you need it to be. And that's the answer to chapter 10, problem number 53.